Good morning everyone. Welcome to my YouTube channel. It's a short video. I'm Dr. Lokesh Gupta. Today we are talking about the partial correlation. In researches, partial correlation is very important. If we are interested to control our variable role, suppose there are some variable that we are assessing or we want to control the role of this variable, so we can use this partial correlation. If we talk about the partial correlation, the important point in partial correlation is that is the extension of even partial correlation and multiple correlation both are the representation and important extension of the theory or technique that is of correlation. Simple correlation is bivariate correlation. There are two variable A and B, or we just want to calculate the relationship between A and B is called simple correlation is the bivariate correlation or two variable correlation or linear correlation as well. So if we add one more variable, suppose we are interested to assess the role of C as well. So if we add more variable in our research, A, B, other than this A, B, we add C, D or E, maybe some other variable. So obviously three or more variable is the extension of our research. So it's called maybe partial correlation or maybe multiple correlation. But today we are talking about only the partial correlation. Partial correlation is often used to analyze in which the effect of some variable or variable are to be eliminated. So now we want to see the relationship between A and B, the elimination of the role of C. So whenever we talk about this is the example, it's a beautiful example. Suppose we are interested to see the relationship between general intelligence and the social economic status. So there are two variable score of general intelligence IQ and the score of our social economic status. So we convert social economic status as a our our ratio is our interval scale. So in this case we have scores range from IQ is in a again interval scale, social economic status and number of hours spent in a day for study. So there are three variables in a continuous sequence. So now we have a relation, we want to see the relationship between these variables. In this case, suppose we are interested to see the relationship between IQ and social economic status. Suppose part one, so suppose circle 1 is denoted for the IQ and second variable is our social economic status SCS, and the third variable is our number of hours studying for in a day. So now suppose there are three variables. So now relationship between these two variables, this is the common variance explained by variable number 1 and 2. So IQ and social economic status have a this much of common variance. But in real research, maybe it may be more or it may be less. It totally depend on after calculation of correlation. Okay, but there is a chance कि maybe C also have some effect on these variables. Due to some C, they are related to each other. So this part, if we suppose we highlight this part is considered as the our role of our due to third variable. Third variable means number of hours we spending for study. So in this case, if we want to calculate the true relationship, so in this case this is the true part of our, sorry, the different color, yeah, this is the true relationship part of our variable number 1 and 2 means IQ and social economic status. So through partial correlation we can calculate. So now we go for formula. What is the formula and what is the meaning of this one? R12.3. This is the denotation of our partial correlation. Yani it means relationship between 1 and 2 and the partial out of relationship of 3. So it means general intelligence IQ and social economic status relationship partial out the number of hours spent in a day. तो simple formula है, we can make a even our own formula as well. So 1 and 2 relationship between 1 and 2 minus relationship between 1 and 3. 1 and 3 means 1 and 3 means general intelligence and the number of hours correlation between these two variable, and the relationship between 2 and 3 means social economic status and the number of hours relationship. The correlation between, so now first of all we have to calculate the bivariate correlation between all possible combinations. So there are total 3 possible combination of bivariate correlation, and after that we just put every correlation value in this formula, or we can calculate the partial correlation. So r square 1 minus r square 1 and 3, so is the again it's a denominator. Okay, so this is the way. And the after the final calculation, even we make on our formula, if we want to see the correlation between 2 and 3, means social economic and number of hours, partial out 1 IQ. So in this case, correlation between 2 and 3 minus correlation of 1 and 3. 1 and 3 means general intelligence and the number of hours we are spending. So in this case, if we see the formula, we are making 2 and 3 means this way. Okay, in this case again, in a second part, relationship between 1 and 2. 1 and 2 means this one. So this is the part, and 3 and 1 again the next possible combination. This is the, and again we just use the denominator for these values. This is the way we can make any partial correlation formula. Now we take a hypothetical example. Suppose in this case we calculate the correlation between, first we calculate the all possible correlation. All possible correlation is correlation between IQ and social economic status is suppose 0.60. Correlation between IQ and number of hours is 0.50, and correlation between social economic and number of hours is 0.70. So these are the 3 possible combination of correlation. So now we want to calculate the partial correlation for correlation between IQ and social economic status. So obviously IQ and social economic status have a correlation of 0.60, but we want to partial out the relationship correlation of relation of number of hours in a day. The formula for this is R12 minus 12.3 is equal to R12 minus R13 R23 and 1 minus R square 13 1 minus again R square 2 3. So now we just put all values. The correlation between 1 and 2, 1 and 2 means IQ is 1 and social economic status is 2. IQ is 1 and number of hours is 3. Social economic status is 2 and number of hours is 3. So now relationship between 1 and 2, 1 and 2 means it's 0.60. 0.60 is the relationship between 1 and 2. Correlation between 2 and 1 and 3 is 0.50, and correlation between 2 and 3 is 0.70. So we put all these values. Now we just put the values and calculate it. So 0.50 and 0.70 square. Okay, so 0.6 minus 5 multiplied by 7, so it's 0.35, and the 1 minus 0.5 square is 0.25, 0.7 ka square it's 0.49, 0.25 is the difference between 0.60 minus 0.35, and the value 1 minus 0.25 is 0.75 and 0.51, and finally 0.86. If we under root the 0.57, so is 0.866, and 0.714 for the under root of this 0.51. So finally 0.25 divided by 0.61. So the correlation between 1 and 2 partial out 4 is 0.41. So it means if correlation between IQ and social economic status is 0.60, but if you partial out the role of number of hours spending in a day is 0.40. So now we can interpret on the basis of these process. So this is called the partial correlation value. Now we can interpret the real relationship between IQ and social economic status if you partial out the role of IQ is only the 0.40, not 0.60. But important thing, it doesn't mean this is the true relationship between IQ and social economic status, because we just assess the number of hours in a day they are studying. But other than these, there are a lot of variables that also play important role. Maybe they significantly affect the relationship between IQ and social economy, but we are not studying these variables. So other than this means error variance. So due to maybe some error variance also included, error part is also included in point 4.1. So we can't say that, we can't interpret that IQ and social economics have true relationship at point 4.1. Okay, so thank you for watching this video. If you have any doubt regarding the partial correlation, you can send me in comment box. And thank you. Please subscribe this channel, see this channel, or like this video. And thank you.